So hello again here from my blueberry farm. I finally found some time to work here on my battery bank a little bit to make few changes. And, and finally I will shoot this video about the battery bank. Today, January 7th, I think, was quite sunny day. So my battery bank is at 100%. So first let me start with the cells. I purchased these cells from Alibaba, 272 amp hours cells. And the cells, they came with these copper bars, and as you can see, very easy to connect the bars. I have 8 banks total, so the configuration is basically 16S 8P configuration, 8 banks in parallel. For the parallel connection I use this 1.5 millimeter cables, silicon cables. So I connected, this is for me cell number 16, connected to the next 16, the next. Here this bank and this 16, they come here in this electrical harness, and from here comes to this 16, to this 16, and I close the loop with this cable here connecting this two 16s. So basically all cell number 16 is connected to each other, 8 of them, and the same with the cell 15, 14 and so on. Here as I told you, the cell 16 here, both of them are coming here in this harness, and the BMS leads that are here on the bottom, the red wires here, they take information from this harness, and this way the BMS know the voltage of each cell and do its job. From the same harness, as you can see, the yellow, the blue, the green wires, these are the leads for the active balancer that I'm using. So as you can see, this is a very important piece here in my battery bank. So it would have been better if just like these 2 banks are connected to this harness, all 8 banks are connected to it, but I didn't have enough space to make all this happen, and now the BMS measures only these 2 banks. Better to measure all 8 banks, but I did everything so it measures only these 2 banks. And that's why it's very important, for example, when you work on your system, to not forget to lift the breakers. So these 2 banks always are charged and discharged, because if you forget, the BMS will not read the correct voltage of the other cells, and that will be a problem. That's why if you're doing something similar, the best will be all 8 to be connected to the harness. So if, for example, one of the banks is not working, the difference for the BMS will not be too great. What else? As I told you, the BMS is connected here for the voltage information. Also, the BMS is connected to this pre-charge unit. This is, I guess, some Chinese pre-charge unit, which is very poorly made. As you can see, you can select 2, 4, 8 or 11 seconds pre-charge time, but this pre-charge time doesn't, even if I select the 11 seconds, the maximum pre-charge time for this particular unit, the maximum is 6 seconds, and these 6 seconds are not enough to pre-charge my big Sunny Island. These are 6 kilowatts Sunny Island inverters. They have very big capacitors inside, and 6 seconds is just not enough to pre-charge this inverter. So because of that, I ruined one of the contactors. Because of the rush of energy, it welds the contactor inside. I did break the weld banging the contactor a few times on the ground, but the contactor stopped working properly. It was heating up a lot. But that's actually also useful information, because if the contactor is not working properly, it will heat up, and it will heat so much, over 100-150 degrees Celsius, that can start a fire or something. That's why I placed this temperature sensor. The BMS, it has 3 temperature sensors here on the left. You can see the 3 cables. And one of the sensors is on this side. One here is the lowest temperature in the winter time and low down. And the third sensor I place here on this cable, so if something happened to the contactor and starts heating up, the BMS will cut everything and shut down the system, so it will prevent a fire or something. So the BMS, as I said, is connected here. Also the BMS is connected to this little screen. There is, you can see some useful information here about the state of charge, but actually from this screen you cannot change anything. You just can monitor some information. Actually, you don't need this if you also have this R.E.C Wi-Fi module, because the Wi-Fi module is connected via Wi-Fi to this pad, and the same information that you get from this little screen you can see here. You can see and even do some settings here from the screen. So here you can see some of the settings I have. Also, you can do some more settings here in the firmware screen. Here, where is the manual communication with the BMS, you can send some commands over there. The rest, I think they're useless. And the BMS is connected also to the Sunny Island inverter, of course, and communicate with the Sunny Island and tells the state of charge and all it needs to know. So this BMS, it's working okay. It has some balancing function that is absolutely useless. You know, if you have this kind of battery bank, they put some resistors inside the BMS, which is useful maybe for if you have a battery for a motorcycle or something, but absolutely useless in this kind of situation. I turned off this function the first day I installed the BMS. All you can do is destroy the BMS with high temperature if you use the BMS for actually balancing the battery pack. For balancing, I first used only one of this active balancer. This is you can see here a NEEY smart active balancer. So at first I used only one of these active balancers, but one balancer is just not enough for this big battery, because winter time, for example, they could be month without the battery reaching 95-100%. And because my pack is top balanced, I can only balance the pack when the state of charge is between 95 and 100%. So when there is not too much sun, the battery will be unbalanced, because there is no time to balance it. And if, like a sunny day like today, if it reaches 100%, it needs time to balance it, and one balancer is just not enough. So that's why here I installed a second balancer. On this side, between these two banks, I installed third one, and here on the top between these two banks I installed a fourth battery balancer. This balancer here is connected to this wire that come between these two banks, and this wire is not cut, only the insulation is removed with this kind of instrument, and then the wires for the balancer is attached and insulated again. The same here between these two banks. Here the insulation is cut and the lead is connected. And you know, if for some reason you're not able to buy this instrument, you're really fucked, because I use this one for everything, for this cables, for many applications here in the electrical construction. This is one of the most useful tools you can buy. So now these four balancers, the NEEY balancers, they work perfectly, and my pack right now, as you can see here, it has 0.001 millivolt only difference in the pack. Actually, no difference in the cells. And here on top you can scan, and I can see all four of my balancers, and you can choose one of them to work with. This one was actually turned off. And you can choose the balancer, do some settings. These are the settings. Once you do the settings, you don't actually need to do anything anymore. These are the settings. It starts to balance when the battery reach 3.4% and will stop balancing when it reaches 3.35%. And it does an excellent job. Okay, so that's about the balancing. Before that, when I had just one balancer, I had to manually balance actually the cells. I had 2-3 cells that were running away, so I had to manually adjust this few times in a year. And the way I was doing this, I used one of the small chargers that you use for, I don't know for what they use them, but this is 500 milliamps, half an amp charger for 4.2 for lithium ion batteries. Even though it's 4.2, when I connected here, for example, I connected just to show you what I was doing. So I would connect the plus and the minus here, because this has plus and minus. So I will connect the plus to the plus and the minus, and I will just plug it in a 240 volt socket, and it will add like 10 amps of energy in 24 hours. And in this way I can adjust a few cells that for example have a low voltage. And if there are some cells with a higher voltage, I was using a cable like this. I think this is like 1mm cable. So there are two cables here connected to one side and the other side of the cable. And I will just contact one cell, the plus and the minus, and the cable will heat up. I actually measure this, and I will draw 15 amps with this cable when I short the cell. So I can discharge a cell with 15 amps with this cable. It's much faster than if you use a light bulb or something. And I'm no longer using this because with this 4 active balancer, they're actually working perfectly now. What else? About the BMS, as you know, this is the second BMS that I'm using, because the first BMS I had problems with it. But later from the company they told me that the reason was that I was using a fuse, a breaker here on the minus part. Before I was using this breaker, DC breaker. It's a double pole breaker, but from the R.E.C. direct company. They told me that, and actually I saw this on their site a few months ago. They posted, maybe I'm one of the reasons they posted this, that there should not be any breaker, switch, fuse or anything between the negative and the shunt. There should not be anything between the negative and the shunt, the negative of the battery bank and the shunt. And before that I had this breaker. So they told me that it was because of this breaker that the BMS was something broke inside the BMS, and that the BMS needs to have a constant to be constantly connected to the negative of the battery when it's working. So that's why I had to remove this breaker, and instead of the breaker I put this hardwired lug. So now the negative is straightly connected without anything between to the shunt. It would have been the best to be without this, but because I already have the cablings here, I just connected these two cables instead of connecting from the negative directly to the shunt. Also, you can see that this is my negative cell number 16, and this is kind of wrong because this should have been cell number 1, and this should have been the negative because it will be closer to the shunt. But because I was waiting for some components, and while waiting I decided to make the cables, and at the time I didn't realize that the shunt should be closer to the negative, and I had made the cables, and then later when I started to put everything together I realized that this should have been the negative, but I already made the cables, so I didn't want to throw away the cables and make new cables, so I put the negative on the other side, and now the length of the cable is actually 1 meter longer than if it would have been if the negative was on this side. That's not a big deal, but maybe the shunt measurement for the electricity that passes through the battery bank is a little bit off. I actually see a little measurement differences here, maybe because of the resistance of this longer cable. It's not a big deal at all. Also, this cable links, let's say this negative is connected here, and all 8 banks, let's say this, you can see 4 cables on the top, but there are also 4 cables on the back here on this copper plate. And it's the same on the shunt side. We have 4 wires on top and 4 on the back, so all 8 banks receive the same length and the same wire. so they have the same resistance when they receive the electricity from the inverter or to the inverter. So these 4 cables, they are the same length, so they have the same resistance. The length of the negative and the positive could be different, but all 8 negative cables should be the same length, and all positive cables should be the same length, so they have the same resistance. Also, as you can see, I break the positive side of the battery bank on each bank with this 80 amp fuse. This fuse is not polarized, and this is much better than the other one that I use, because this one is polarized. You need to connect this breaker in a certain way, but because the battery can give electricity but can also receive electricity, it's best to use this kind of non-polarized breakers. I'm not 100% sure, but I think this is a non-polarized. I read in one of the sites that I purchased that this is not polarized. I hope they didn't lie in the description, but there is no, like you see on this breaker, you see how you have to connect it, and this one, I think it's not polarized. So here I break the negative from the battery before going to the contactor. Okay. Oh, now that I say the contactor, I think I forgot to say that this pre-charge unit, it's not working as it should, so that's why I decided to use this resistor. So I use this resistor to actually manually pre-charge my system before starting the BMS. So the procedure will be, I will short the contactor that will send electricity to the SMA inverter, and when I'm sure, keep it for some time, and I'm sure that the capacitors are pre-charged, then and only then I will start the BMS to make sure that the contactor doesn't weld. So I advise you to not trust this pre-charge unit and actually manually pre-charge your inverters. Okay, so now that I break the positive here, it would have been best to use my main fuse box to break the negative, but because I didn't have enough space, I had to break the positive again. If I had enough space, I would put this shunt here in the middle and break the negative, but because the contactor is tall, and if I put it here, it will interfere with the fuse box, and just didn't have enough space here to do it like here, break the positive and then break the negative, but and I had to break the positive twice. And because I didn't have enough space, I also have had to make some other compromises. Here I even dug inside the wall here to get few more centimeters here and on this side, and because I didn't have space, I had to make the construction here for the battery cells. You see how here the support is on the side, but because I didn't have enough space on the back, I had to put this on the back, so the support is not so strong on the back. And actually here, that's one of the things that I'm really proud that came to this idea to put the battery cells in an angle like this. So as you can see, it's so easy to work with the cells, great visibility, and also it saves so much space, because if I had to put the cells vertically, you need to put some spacing between each row, and that will take so much space. And how I did it, I used this L-shape metal here, and the battery, it's sunk inside here. I use this plastic that is usually used for flooring, for finishing the flooring. Here I put it on the wall like this, but I use it to cover the metal, so here on both sides, so the battery will rest on this plastic and not on the metal. And here, because this was made for installing the batteries vertically, I had to cut this part here, and now I have only this thin metal part that is holding here on the side. If I have to do it again, I will put something much more thicker here on the side, because you can see that the battery, they really expand with time, contracting and expanding, and they expanded, so they compressed a lot here and bent the whole structure. It's good that I put at the beginning this L-shape metal, so if one day I decide to remove the cells and rearrange something, I can kick out this L-shaped metal with a hammer and have this 5 millimeters to remove the cells. Some people, they compress the cells before they start to use them, but I think this is absolutely not necessary. Just keep them together, they will expand and compress themselves. And as you can see here, because here on the back is a little bit weaker, because I didn't have space to put that part on the side, maybe you can notice that this whole pack is a little bit curved here on the top. You can even see a little space here forming, because the front is holding better than the back. I also have this metal sheet here from the top to the bottom on both sides to hold the cells better together. So that's it about I'm very happy with this design, that I put the cells on an angle. What else? I'm forgetting something, I'm sure, but here this fuse is it has three. I use only two of them, three fuses, but they have 250 amp on each side. And I have one reserve here for if I decide to install a third Sunny Island inverter. So I will easily connect the third inverter to my whole system here. What else? What else? Maybe I repeated myself a few times, but I just want to make sure that I say everything. Here also I put these brackets here just in the future to cover everything up, but this is still something that I'm going to do in the future maybe. Everything works very nicely, and apart from the first BMS that according to them it was my fault, so far everything is working excellent. Very happy with the whole thing and everything. Okay, if I remember something I forgot, I will write it in the description below or make a new video. Here I think I already mentioned that winter time the temperatures here get below 5 degrees, so I have this automatic heater that if the temperature drops below 10 degrees it will start heating up the room. It will work for a short time and shut down. And for ventilation I have this other system that winter time I'm not using it. During the day the heat that these inverters make, they heat the room, so that's very beneficial in the winter time. But in the summer I have to ventilate the room. But winter time is very beneficial, this heat, to heat the batteries and in the room. And that's it. I think that's all. Good luck and Happy New Year.